Bam! Hey, welcome everybody. Dr. John here for Extract Talks. How you guys doing? Thanks for joining us. We're continuing our podcast series really on sustainability and environmental, sustainability governance, ESG, and how that's really impacting, places such as the S&P 500.
Yes.
I mean, people are really looking at this from an investment standpoint and saying, hey, look, we want to have environmentally sustainable investments. And so we think that this is a big deal for people who are starting to more, doing operations. If you have the ability to do an operation and you can show, hey, look, this was made in a very environmentally sustainable way.
Yep.
And hey, look, the consumer really actually does care about this.
Yes.
Which they do.
Yep. It's a big thing.
We talked about that before, like 1 gram of ethanol extracted, oil
cartridge
costs the environment over 95 pounds of CO2. 1 gram. Versus 1/4 gram for a CO2 extracted, 1 gram of CO2 extracted. Quarter pound. Yeah, quarter pound. Yeah, quarter pounder.
A quarter pounder.
Yeah, a quarter pounder versus 95.
Yeah.
Weed's next big problem is the wrong type of green.
Ooh.
Yeah, so this is an old article, actually. I sifted this off. I think you can find it on the web and everything. But a lot of these people have been doing, kind of focusing on the grows,
Yep. Growing and production definitely seems to be the big thing when you hear sustainability.
Yeah. So, they looked at the grows. They said, oh, well, it costs a lot in CO2 to heat these
all those indoor grows. Yeah,
all the lights and everything.
That is no joke. Controlling the environment. I mean,
they got the little meter in the back spinning like this, all the kilowatts going.
Well, right? of that 91 pounds, I believe we found, 41 pounds to create 1/8 of indoor flour.
Oh, wow.
So again, if that flour is getting turned into a final product like a vape cartridge or a tincture, it's skyrocketing.
Yeah,
even higher.
So not only with the CO2 indoor grown, the greenhouse gas footprint, if you will, of that eighth of flour.
Yep.
I mean, that itself is costing a lot of CO2.
A lot.
Yeah.
And I don't think people really understand it. That's why we continue to educate.
Right.
Let people know.
It'd be better if it was outdoor then, right? Rather than indoor.
Absolutely.
Right.
I mean, there's still costs associated with that, whether, financial or through the environment.
Right.
So, but it's much, much less. And realistically, I think in the future, that's what a majority of it's going to be.
Right.
Farming.
So, so what we've been doing is kind of looking in greater detail at the ESG parameters associated with operations, because we're kind of operational people here. We deal a lot with operations. An investor will come to us and they'll say, okay, how much does it cost to run this facility? Actually very few ask the right questions.
Right.
Because there's so many hidden costs, and a lot of times they're relying on their technical people, and they're like, oh, I don't really know. The technical person's just going to do what's kind of trending in the marketplace.
Yep.
And sometimes those trends are very unsustainable.
Correct.
And they're also very costly. You really have to do the math, investors. You have to do the math. Yep. You have to do your sustainability calculations. You got to do it. It's really not that hard.
No.
You can
just have to know what you're trying to calculate.
And the numbers you really should do.
Yes. Yes. So, absolutely. That's, again, the numbers. What you're putting in is going to be what you're getting out. And if you're investing in something that's going to cost you a lot of money to sustain, it's probably not going to be worth it. Right,
exactly. So what we decided to do was what's called a life cycle assessment. And this is based on ISO 14064, which really it is a process in which you can basically assess your organization for carbon footprint.
Okay.
And a lot of people have been involved in really, BMW, I think, if I'm not mistaken, they've put out a car, for example, that's ISO 14064. I hope I got the brand right there. But I think it is, where they've looked at the environmental impact of all the plastics
of producing that particular car.
Yes, exactly.
Okay.
So, and they use this ISO standard. And so I went in, I looked at it, I looked at the, all the highlights. And the EPA publishes this process called the life cycle assessment, or the LCA life cycle assessment. And really what it is it's scoping the project, and then, what's in, what's out, and then looking at all the parameters for inputs and outputs of heating and energy, and then converting those over to a CO2 number.
Okay. Just kind of like we did last week.
Yeah, right, exactly. So with ethanol, we really looked at, okay, what is the greenhouse gas emissions from heating and cooling thousands of pounds of ethanol?
Yes.
What are the greenhouse gas emissions specifically related to using ethanol?
Right.
And then reusing ethanol? And then what about, what are the greenhouse gas emissions associated with, for example, the VOC?
The waste.
The waste, right? The smog forming.
Yeah.
And we talked about all of that. And we really kind of ignored CO2. We made the claim that, hey, CO2 is orders of magnitude better. But we're going to, in this podcast, we're going to kind of get into that a little bit more.
Yeah.
But I wanted to tell you that, hey, this is what we really looked at. We have this life cycle assessment. We use this ISO 14064 loosely. We are not certified to that ISO standard.
Right,
okay?
right.
So, but we're using the same, methodology that has been published before. So, looking at heating, cooling, chemicals, operations, fertilizer, pesticides. Like in a grow, oftentimes they'll burn propane.
Oh yeah, to get the CO2. And
why do they do that?
I don't know. Well, they don't have a CO2 machine where they can just throw the biomass in there and pump
That's
that
true.
into the
That's
grow.
true.
And it could be a lot easier.
Yeah, a lot of our customers will have a grow. If they do have a grow, oftentimes there's some venting of CO2 that comes off of the extractor, and then they
it
put
just
that
happens.
they put that right into their grow.
Right.
And so in that case, it's reused.
Yep.
There's other things that you can do with that. You can sequester that CO2 also with some devices, which we can talk about later. But, just so disposal of waste materials, outgassing, VOC, we talked about that.
Yep.
Ethanol coming off of spent material basically, or raffinate material. So, and then solvent emissions, outgassing. So those are the things that really we're talking about. So let's kind of get into it here. Key sustainability factors for extractors and processors. Again, we're looking at energy consumption, solvent selection, solid hazardous waste generation, spent solvent incineration, organic carbon pollution, and hazardous air pollutants. So those are the things that those are the key areas.
They're going to help a person figure out
that we
what they need
actually
to focus on.
quantify in every one of those for the two different processes or three different processes. It's a means of comparison.
All right.
Okay, and so people are always wondering, okay, we want to compare apples to apples, right?
Right.
So what we did in this particular setup was says, okay, for 2,000 pounds, we're gonna process 2,000 pounds, and then we're going to calculate the amount of carbon footprint for 1 month worth of operation, which is 2,000 pounds. And we're going to compare that for using all of those parameters, basically for CO2 and ethanol, and we didn't do butane yet.
No.
We could do that, but So so let's kind of fast forward to it. We already kind of talked about the energetics of solvents and we kind of came up with this sustainability pro and con.
Yep.
And that's essentially here you got the cons of the ethanol extraction really are the VOC and the HAP emissions from the ethanol losses.
Yep.
We got the high energy GHG, in other words, greenhouse gases to produce the ethanol itself.
Correct.
And then we got the GHG used to heat and chill ethanol. I don't know.
Yeah, I mean, it's just so much. Keeps adding up here. Like
it's adding up. Yeah, gonna get a little calculator.
Yeah.
We're gonna make a calculator for you guys so that you can go ahead and toggle in your own parameters.
Yep. Figure out how sustainable your product was.
Yeah, basically. Yeah. So touched on this a little last week, but CO2 is a colorless, odorless, inert gas. So now we're going to go into our assessment of the CO2 side of this.
Yep.
So this is kind of the calling card, if you will. This is the benefits of CO2. If you're using it in a solvent setting,
right.
So it's non-toxic. It's used in food processing, so it's safe and. There's no maximum limits, for example, of CO2 in a product.
Right. So you
There
don't have to
aren't.
worry about
There's not the
poisoning
5,000. Right,
5,000 ppms.
Yeah.
No worries about that.
No
so
worries
it's
about that.
Safe to worry about or safe to work with.
And the impurities are quite inert.
Yeah. I mean, I think the benefit to me is I know it's been used in food. It's in beer. It's used to decaffeinate coffee, stuff like that. So, I mean, automatically.
Hopefully it's not bad because we're breathing it out.
Right. We're breathing it out. So tons of benefits to CO2.
So how is CO2 made? That's really where we're comparing now. Ethanol is made, it's got a big carbon footprint, 131,000 BTUs per gallon it takes to make a gallon of ethanol. Okay, so how is CO2 made here?
Did they have just like a bunch of people breathing into bags?
I don't know what
they kind of.
I think it has to do with the fermentation process.
Yep. I looked into it. There's a little bit of a
but even more, I think it's just very, very energy intensive. Okay, because I like a lot of that CO2 is recaptured and reused.
Right. So, it's a byproduct of a lot of other industries. Right. We're still looking for beer makers that want to send us their CO2 so we can make some. What would we call it? Beer. CBD or
CBD beer?
CBD beer. We got to still come up with a snappy name. So if you got something for that,
CBN beer.
Yeah, get a hold of us.
CBG beer.
CBC
beer.
Well, we're gonna do something. Yeah, we're gonna do something.
Do something like that. Yeah. So
CO2 and CBD somehow.
All right, sounds good. So, Anyway, So here the way it's made, typically CO2. Industrially is recovered from industrial processes that are occurring.
Okay.
And then what they do is they capture it and then they compress it. It becomes a liquid and then they purify that and then they send it out for people to reuse.
Yep.
Okay. So there's actually carbon credits that people get for actually reuse of their solvents. So
all right.
Yeah, so
you're not only saving money on processing, like you can actually get credits for using it, reusing it.
And because of that, basically what it is it's the energy of compression is really what it is. So, it's pretty low. The calculations that I saw that were available was about 100 to 200 BTUs per gallon compared to 131.
Oh, for the ethanol, yes.
So that's a big deal.
Oh, absolutely.
It's a way difference, orders of magnitude different.
Absolutely.
So companies are incentivized to capture and reuse the gas for useful purposes. This is just a good thing. That's what we want, right?
Yeah, absolutely.
So, you can do that or you can sequester it permanently, right?
Yep.
And if you go into the carbon tax stuff, there's you get tax credits for sequestering it. But you got to show that it's permanent and all of that. Yeah.
Yep. There's a lot behind it, and hopefully.
In fact, you wouldn't probably do that with a CO2 extraction facility because there's so little that's emitted.
Right. It just wouldn't make sense.
It wouldn't make sense to do it. So. Okay. So why is CO2 a green solvent? That's another reason why people, kind of asking the question, well, what makes it a green solvent?
Right.
So, this is an article that you can go onto the web and look at. It's ACS article. And basically, these guys from Applied Separations, now they are a CO2 extraction company. Okay. And they have this great little list. They've been in the business for a long, long, long time.
Yep.
Hats off to you guys. You really put together a great list, but they go through all the benefits. It's abundant, renewable, easy to prepare. It's non-eutrifying, meaning it doesn't kill the stuff in the environment. It does not contribute to smog, and it does not contribute to global warming. CO2 is recycled with minimal release. Okay, so that's why it doesn't contribute.
Can reuse
because
it.
You can reuse it, and there's ways to do that. So
nice.
It's not only the ACS saying that, but the chemical engineering groups are saying that. So you can buy books that just talk about comparison and workflows for the different types of solvents compared to supercritical fluids. I'm not going to really go into that in detail, but just suffice it to say that it's very well known in the scientific literature that CO2 is extremely sustainable compared to any condensed solvent.
All right.
It doesn't matter what it is. So
nice.
So here's what we got here. This is it right here. This is the result. We side by side.
We got a lot of numbers here.
Look at that.
Oh, wow.
Moly. So here it is right here.
All right. I see the dollar signs at the bottom. That's
there it is.
What I'm concerned about. And I see it's really big over there by the ethanol.
So this is for 2,000 pounds. So we got 2,000 pounds. We got 2,000 pounds. This is just for the extraction. And then here's the CO2 extraction plus the winterization. And so these are where you have liters to cool, liters to evaporate, kilowatts, hours to cool and heat, kilowatt to heat, kilowatt to evaporate, efficiency.
Man.
Kilowatt hours total per kilowatt per day. Okay, this is the energetics. So it really is a low energy technique.
Yeah,
right? I mean, you're really saving a lot.
Absolutely.
There by doing that. So, we don't really have any means to compare to ethanol with, for example, VOC.
Oh, right. Because there isn't any.
Right.
There is none with CO2.
No.
So that's just.
There is none. So there's no comparison. So
one
if you
up
say
them there.
how much better is it? Well, it's infinitely better because
Right.
because you have 5% that's lost, and so you really can't calculate it because you're dividing by zero.
Right.
Right. So what do you want to do? You want to have, you have to divide by zero, which makes it infinitely better.
Right.
Okay.
Right. There's just no way around.
There's no way around
beating
it,
that.
Right.
Beating
Exactly.
it on that front. So.
You divide by less, you get more. Right. So
Right.
So if you divide a whole number by let's say 0.1, you're going to get a number, right? If you divide a number by 0.00001, it's going to be a big number.
Right.
Exactly. So
So
that's what happens. Okay. So you divide by zero and it's going to be infinity. Okay.
Infinity better.
It's a little advanced secrets of the world mathematicals. Okay. But we all learn this when we're in grade school, obviously.
Yes.
Okay, but so then let's look at the other items. What do we have? Oh, yeah, manifest. Hey, waste manifest.
Oh, yeah.
Where's the waste manifest?
Well,
We do have some waste manifest,
Right.
obviously, because we do use a small amount of ethanol.
Correct.
So you lose 5%, but you're using such small amounts. So
Right.
you do have that. But there's no VOC emissions because you're not outgassing anything.
Exactly.
Right? So
Yep.
what are the other aspects that we have? Low energy to produce, no VOC. May reuse or recover, permanently store effluent for greenhouse operations equals 45 Q credits. That's what I was talking about.
Okay.
Those are 45 Q credits, which are the greenhouse gas emissions, carbon dioxide, like tax credits.
Right. Right. So you can actually get paid.
Right.
For
They're
using-
actually credits.
Right.
Yeah, that
Oh,
means
man,
they pay
that's-
you. That's pretty sweet. You just have to have the documentation for it.
Yeah. Make sure you're doing it right.
So that's the main thing. It's really hard to do a comparison, essentially, because we have no VOC that's being produced. We
Yep.
have the energy, the energetics are, we kind of just went over the energetics.
Yep.
The main contribution really is the energy required to cool down and heat up the CO2, which is not a lot compared to ethanol.
Yeah, ethanol. It's massive.
So then what else do we have to really talk about? There's no HAP that's being generated. There's no VOC.
Yeah.
And there's no hazardous waste either that needs to be incinerated.
Right.
At the
right.
end,
Technically, if it's okay in your area, you can actually feed that biomass to animals or use it for.
Exactly. You can use it. You
find
can
another
compost
use
it.
for it.
You
Exactly.
can compost it, right?
Yep.
Otherwise, so it's a naturally abundant material. So those are the pros, obviously, and the cons are the high startup costs. Now, I don't think that is really actually true anymore compared to ethanol. I think the ethanol producers have they've increased their price. Some of the CO2 producers have decreased their price.
Yep.
So they're a lot closer than what you think.
Yep. Than what it used to be 5 years ago.
Right. Let's go back here real quick here to our level. Yeah. So here, ethanol extraction sustainability. So here, like I said, VOC, we don't have that.
Yep.
High energy GHG to produce it. We don't have ethanol.
No, it's a byproduct.
Well, we do have ethanol, a small amount in winterization.
Correct. Yes.
So that has to be taken into account, but that was taken account but it's so small that it doesn't make any difference.
It's almost insignificant.
Insignificant,
Yes.
yeah. And then high energy GHG used to chill and heat ethanol. Well, you may recover ethanol from, like a winterization process.
Yeah.
That's something that you do.
Oh, yeah.
But there's so small amount. So
Right.
it really does all boil down to the amount of ethanol.
Right.
Again,
the more you're using, the more
So if
it's
you're
gonna have an
using like a
impact.
fraction of, like a little tiny bit of ethanol, and then you're comparing that and saying, to somewhere where you're using a whole truckload of ethanol.
Right.
It's just, you're not going to have
It's just not
the
going to
same.
work.
Yeah, you're not going to have the same. And then the energy losses and the reuse and hazardous waste, those also don't apply because you're not really reusing your ethanol and you're not reusing your hazardous waste. So,
Right.
Yeah, you're just. So anyway, that's the bottom line there. So let's kind of go back to this most sustainable method. Here we have the ethanol and being the most sustainable method. We've seen this now for several weeks.
Yep.
And then we have the CO2, the winterization right here, plus winterization, and you can see that's just not even in the same ballpark.
No. Again, as you see, the longer you operate, the more those costs go up.
Yeah.
And then again, take into account when you actually start scaling up your operation, you're driving it up even more.
Yeah, exactly. So that's with 2,000 pounds. I know a lot of people do way more than that.
Oh yeah, easily. This is 2,000 pounds a month.
Right. But
yeah, there's people out there doing 2 a day.
Right. If you just bring it down though, I don't care if you're doing 100 pounds or even 50 pounds.
Yep.
Still, your carbon footprint for 1 gram of material is still
going to be the same.
The same,
it's significant.
Yeah, it's very significant. So, and that's, I think, what really consumers kind of care about, right?
Oh, absolutely. Absolutely.
I mean, they want to know, has my product been produced in a sustainable way?
Right. It didn't used to be like that. It seemed like, again, 5-10 years ago, I think people were just happy to get products, be able to walk into a store and get something. But now it's like, okay, they're understanding the environmental impact. They're seeing what's going on around the world.
Well, we're supposed to be an eco-friendly,
this industry.
Back to
cannabis
the earth industry, right?
Yeah,
isn't that what it's all about?
Yeah, exactly.
So, I mean, and here we're huge polluters.
Exhausting, yes, all this energy and doing damage to create something that's meant to help people.
Right.
So yeah, we definitely need to bring it back.
A lot of times in some people might say, okay, this is kind of an argument for flour, right?
Right.
And just sticking with flour, and why deal with processing anyway? I think you do have the flour out there, but a lot of people are not going to smoke it.
It has its place. Yeah, that's the thing is your grandma is probably not going to want to smoke a doobie.
Right.
She's probably going to be more apt to doing a tincture or something like that. If you have a minor.
You need an oil.
You need a concentrated product that's going to be easy to use.
Right. So
and consistent.
Yeah, so that's what that is. Now, it turns out, and we have talked about this so many times on this show, really, it's not only a matter of sustainability, it's also a matter of cost.
Yeah,
so
financial.
When you decide to go ahead and produce or build a plant that uses this very high energy, right?
Yeah.
I mean, you are increasing your operating costs.
Oh, yes, huge.
If you have to buy a lot of ethanol, and then you have to manifest that ethanol as waste, and then you also have to have lots of, you can't really do anything with your byproducts.
Yeah.
Those are that's costing you.
Right. Yep. You got a cost to get rid of the ethanol, to get rid of the biomass. Again, it's the costs don't stop.
No, the costs don't stop. So here's some things that we put together, just some good metrics for you. So reasons why, sustainability pays, essentially.
Yep. Oh, yeah.
And, so you use 18 less energy use compared to ethanol. That's a cost, right?
Oh, that's huge.
Okay, 125 less solvent loss cost.
Oh, my goodness.
Okay, 6 times X less solvent startup cost.
This is just
right?
money.
Yeah. So what's the point? Okay, 394 times less cost of solvent reuse and changeover costs. So there's an assumption in that number, the 394, about how many times you're changing over your solvents.
Okay.
And we had talked about that with solvent reuse.
Yep.
So that's something we want to give the, kind of in our calculator. We want to have someone be able to put their number in there.
Right. How many times they're reused.
But, at the end of the day, guys, you're going to have to change over your solvent at some point in time.
Right.
Okay.
Right.
If you keep on using it, it's going to build up contaminants, build up. You're like, oh, well, maybe there's no risk with that. No, there is risk.
Oh, 100%. Yeah.
And so you don't want to use it, to the point that it's super,
you're
janky
extracting with pond water, basically.
Yeah, and it's like, oh my gosh, so that's going to cost you something.
Yeah.
It's going to cost the environment something. So,
absolutely.
Also, infrastructure costs. We never talked really about this, but
yep.
If you're going to have, thousands of gallons of ethanol in a facility, it's going to cost you more to build that facility. It's going to have to be under an H4 occupancy or something versus a general industrial occupancy.
Okay.
Those things cost more. Right?
Yeah.
So,
yeah, absolutely.
So if you add up all those costs over time and you actually do the math, many people do not do this. They do not do the math.
Yep.
We have a calculator that will output this graph, and you can put your own assumptions in there, but we have a calculator. I mean, I would say that people just don't do the math.
No.
They just don't do the math.
No, I'm surprised.
This line right here is the cumulative operating cost for a CO2 extraction for 2,000 pounds a month.
Yep.
Again, we're kind of standardizing on that. And then this is the cost right here for an ethanol operating facility, right?
Yep.
I mean, and you can see there's a difference here in the
Initial.
intercept here. The
Yep,
initial
that
here. That's
initial.
because this is taking into account the initial cost
Of the equipment.
itself.
Yep.
So you can see that the CO2 is a little bit higher cost, okay? But you can see, within a couple of months, it's crossing over. And
Yep.
someone might have some assumptions. Okay, so let's say, hey, Johnny T, I don't think that 394 is really right. I think ours is more like 200x.
Okay.
Okay, no problem. What will happen is this slope will go down a little bit more, and it'll cross over here at 4 months instead.
Right. You're still going to get that massive gain.
Yeah, under
no matter what you-
under no conceivable scenario that I've put in the calculator will it cross over in more than 12 months.
Okay.
So there's always going to be, so
It's just a matter of time.
It doesn't matter, where your operating costs, this is like added cost to actually produce, right?
Yeah.
So yeah,
And you're getting rid of that ethanol.
the calculator also
bringing
takes
new
into
stuff
account
in.
labor and
Oh
all that
yeah,
stuff,
it's a pretty extensive calculator. If you haven't used that, check it out. The ethanol cost comparison.
right.
Definitely worth it.
So hey, so that's really kind of looking at the sustainability factors for CO2. Basically, the scientific literature is quite settled on it.
Yeah.
I would say from the chemical engineering and plant design side of it. Why? A lot of people ask, well, why aren't soy plants using it then? Well, they would if they could, but there's a lot of reasons why, because hexane is allowed and it's so cheap. Okay.
Right.
So
And the infrastructure's already there.
the infrastructure's
for
already
what
there.
they're doing. Yeah.
I mean, I was reading some articles. I mean, people want to put in a hexane plant into one small community, right?
All right.
And then they went there trying to get permits for it.
Yeah,
And then they
how'd that
brought
go
out a
over?
scientist who says, "Hey, this will only produce 100 kilotons of emissions per year. It'll only
Only.
it's no big deal.
Yeah,
Don't
yeah.
worry about it. It'll be
Forget
fine.
about it.
Those are hexane emissions, by the way.
Yeah. Right.
It's no big deal because the FDA says 500 parts per million is okay. You can eat that all day long.
Yeah.
So
I don't want that next to my house. I can.
we should pull out that tincture that we made again.
Which one?
Well, the tincture where we have all the maximum amounts in there.
Yes, that would be fun to do.
Whatever happened with that one?
I don't know.
We should probably rehomogenize it because it's probably separated.
That would be kind of cool to see. Yeah.
Yeah, so
Have to
maybe
do that.
Well, who could we feed it to? Maybe James. Would you take some?
James.
James could do it.
Jen, you'd be passed out by the end of the
Be
show
like-
if we do that.
I had a crazy Russian friend who he said that when he was growing up, they would oftentimes imbibe acetone, and they get drunk off of acetone.
They would drink it to
Yes.
get drunk.
Yes. So
Don't.
yeah, I don't know. I guess it's acetone. I don't.
Yeah, the filter, the liver filter.
But
out all
we could probably that might
impurities.
a little bit. We could see what happens to him. It might be an enhancer.
I'm sure he'd be fine. Yeah.
Yeah, he'd be fine. You'd be fine. You be fine, James. All right. Well, what do you think?
Yeah.
Close it up?
I think so. I think we covered quite a bit.
Okay. Well, you guys, thanks for joining us. Appreciate all your time and really good talk. Good meeting you guys. If you want to, please leave some comments.
Yeah, don't hesitate not to ask us whatever you want,
Right.
on or off topic. We love
Right.
talking about the topic at hand because that will allow other people to see and
Right.
and learn and allow the industry to continue growing.
Right.
So don't be afraid to chat with us. We like
You're right.
it.
Give us the
Like
thumbs
it.
up too. If you like this content, even if
Yeah.
you don't like the content, give it. I mean,
Yeah, let us know.
Let us know. Yeah. So let us know, and happy to interact with you. We always talk that. Please subscribe. Also, there's at the very bottom of the YouTube videos, we have all of our links in there.
Oh, yeah.
Go to extractlab, extrakt.com/resources.
Yes,
We
that is.
have tons of stuff there.
Oh my! You're gonna find something that you want. Again, whether it's a guide, a calculator, one of the calculators we've been talking about, mini courses, the podcast. We got everything for everybody.
Yeah.
And if you're in the hemp or cannabis industry, I mean, this is definitely something you want to take advantage of.
Yeah, and we've been adding so much to it too. I mean, we can't stop.
No,
we can't stop.
it's
like, oh
definitely
my
hard.
gosh. Well, okay, well,
Well, by the time we get done with something, there's something else we think of, or
Yeah,
hey, people need to know this.
Well,
you
like
know?
kind of like the sustainability stuff. I mean,
Yeah.
it's just started to come up. I mean, it's taken the, I was really surprised to see, the article from MJ Biz Finance, and then
Yep.
I started looking at it, ESG. Some of our customers started talking to us about it. Yeah, we want to have an ESD.
Never really took it into account.
ESG.
It's
Yeah,
it's kind of one of
we
those
have to have an ESG operation. Our governance is sustainability first. Okay?
Yep.
So a lot of people are like, okay, well, that's what we need to do, and so you tell us how to do that.
Yeah.
Well, I just happen to have the calculations done, and then I typed in ES&G based on the MJ Biz article, and I'm like, wow, this is a really big thing because all these companies now are they're making their investment decisions based on that, at least a factor. Right?
Yeah. It may not be everything, but again, moving forward, a lot of consumers are starting to take this kind of stuff into account, and you're definitely going to want to be on the side of making the right products.
Right. Yeah. Also, from the consumer. So, okay, we can close this up.
Yes, we could talk all day
thanks.
about it.
Thank you guys.
Oh, I thought
Appreciate
we were
it.
coming in for
Bam!
the high five.
Oh yeah, there I am. I got that. It's all good. So,
Yep.
thanks a lot for joining me, Jared.
Yeah, absolutely.
Okay, no
Thanks
problem.
for having me.
You take care.